This means that b squared equals, 1 squared is 1. Bring the x squared to the other side, so subtract x squared. One more step to get b. Square root, right? Both sides. And this will be here.
Oh, so you don't take the, you don't leave it as 1 minus x?
Oh, I was just going to mention that. Remember that when you take a square root of two things that are separated by subtraction, you cannot do the square root of each one, right? You can convince yourself of this if you just give yourself an example. What's the square root of 9 minus 4? Is this just, do you just take the square root of each one? Like the square root of 9 would be 3, right? Square root of 4 would be 2. Or is this just really 3 minus 2 is 1? Is it? What's 9 minus 4? 5. What's square root of 5? Well, not 1, right? This is not right. You can't do that, right? If you're ever unsure, just check it with, just give yourself an example. All right, what did I do that for? I wanted to, why is that not coming on? I wanted to show you what we just did. We haven't finished, actually. Let me move this projection thing up. Okay, we have this side, right? What are we looking for? Tangent, right? So tangent, so what we're saying is that this is equal to, tangent is the opposite over the adjacent, right? That's the algebraic expression. So I know you're looking at that going, what the hell are you doing? I'm going to project this over here so you can see what we just did. So what I'm going to do is I'm going to have this computer graph for us y equals the original trigonometric expression. So I'm going to have it graph tangent of cosine inverse, I think I can type arc cosine, yeah, of x, right? There's the graph. You all see that graph? You see it over there, but I'll drop the projector. That is the graph of tangent of arc cosine of x. There's the graph. Now what I'm going to do is I'm going to have this graph, what we just did, the algebraic expression, which was the square root of 1 minus x squared, right? All of that divided by x. What is it? It's the same thing, okay? So we have found a way to convert a trigonometric expression over to an algebraic expression. So in a calculus class, we might have a trigonometric expression that we need to do something with it, and it's better if we turn it into an algebraic expression first. And this is the process for doing that. All right. Trying to decide if I'm going to leave this on. I just have a few more, and then I'm going to have you work some problems on your own here. I think it'll be more constructive for you to work on some stuff. Y'all want to do one more of those algebraic ones? You want to see another one? Ooh, yes? All right, let's do one more algebraic one. How about sine of cotangent inverse of x? Sine of cotangent inverse of x. I want us to take that and convert it to an algebraic expression. So same instructions as we just had. So every problem that I've given you today that has this form, like since we started this section, this has always been some angle, right? That we're trying to figure out what that angle is. And so ultimately here we want to know what sine of that angle is. Right? What is it? Sine of that angle. Well, we write down over here what's cotangent inverse of x. Well, that really means cotangent of some angle is x. Then I draw a right triangle. Here's theta. Cotangent is which side over which side? Y over x, y over x. What is it? X over y, or adjacent over hypotenuse. Either way, you can look at it either way, right? So I need to rewrite this as a fraction first. I'm going to write x over 1. And did I say adjacent over opposite? Well, I said hypotenuse, didn't I? What is it supposed to be? Opposite over adjacent.
Cotangent's adjacent over opposite, because tan is opposite over adjacent.
I'm getting myself all upside down here. Okay, tangent is opposite over adjacent. Cotangent is adjacent. I said hypotenuse. I'm all out of whack here. Okay, there we go. Y'all agree? Yes? Maybe? We'll just guess. No, cotangent is adjacent over, it's this over this, right? This over this, not this over this. So this side I'm going to label x, this side I'm going to label 1. And ultimately I want to know what sine of theta is, right? So sine is opposite over hypotenuse. So I need to know the hypotenuse, don't I? And I can get the hypotenuse because I have 2 of the 3 sides. So let's call it h for hypotenuse. And so I know x squared plus 1 squared is h squared. That's x squared plus 1 equals h squared. Take the square root on both sides. Square root of x squared plus 1 equals h. So that goes here. And that's it. We just get sine of that now. So sine, by definition, is opposite over hypotenuse. So that means this, written as an algebraic expression, is 1 over the square root of x squared plus 1. So if I graph this and I graph this, I should get the same graph. Now, there are some domain restrictions, because remember, when we do this, we don't really know what quadrant this triangle's in, so there are some domain restrictions. But when you're doing algebraic expressions, you don't have to concern yourself with that as much. You just get the algebraic expression. All right. Yeah.
You don't have to set the denominator equal to 0 and work it out to figure out if something is not an answer?
Well, what I'm saying is we're kind of waving our hands at the domain. We know there's domain restrictions here, right? Cotangent being cotangent being x means that this x has to have a certain domain restriction. Whatever we plug in here, like we can't plug 0 into this, right? Because cotangent of 0, cotangent of 0 is okay. We can plug anything into cotangent, right? Yes? Anything can go into cotangent? Inverse? Think about what cotangent looks like. That's cotangent, right?
Yeah.
So the inverse function can take any value and send it back to anywhere between 0 and pi. So for this particular one, there's no domain issues. And for the one we did before, I'd have to look at it again. But there are restrictions if we're using, like, let's say that this was sine inverse. Then we would need to make sure that what we're plugging in is not bigger than 1 or less than -1, right? We have to be within the constraints of the inverse trig function itself. Assuming that we are, then this all makes sense. But when we get to the end, we don't need to check anything.
Okay.
All right, I have one more little example, and then I'll give you something to look at. Sine inverse of cosine of 7 pi over 6. Now this is, I'm not asking right here for you to give me the algebraic expression. What I'm doing here is saying find the exact value. No calculators, in other words. Is this an angle? No. Now, see, I'm trying to trick you. See that that's not an angle? Why is it not an angle? This is not cosine inverse. Every problem we've done up to this point, this has been the inverse function in here, right? And then the regular trig function's been out here. I've switched them, haven't I? So when you have this, you can't say, oh, that's theta. I really want to know what sine theta is or anything like that and draw a reference triangle. For this, you're just going to have to figure out what it is. Now, do you know what cosine of 7 pi over 6 is? Yeah, so you're going to the unit circle, right? 7 pi over 6 is right there, right? 7 pi over 6. What's cosine of that angle? Negative root 3 over 2, right? Right, that's the x-coordinate. So this is really just sine inverse of negative root 3 over 2. I got it? The reason I'm doing this problem is everything we've been doing, I don't want you to get like stuck in tunnel vision and think everything we do is the way I just did it. I mean, you have to pay attention to what it is you're trying to accomplish. This right here, I can figure out what this is. And then I can take sine inverse. How do I do this? This really means what? Sine of some angle is negative root 3 over 2, right? Which means where on the unit circle is your, which coordinate? Y coordinate? Negative root 3 over 2. Where's that happening? Where's your Y coordinate, negative root 3 over 2?
Negative pi over 3.
Right here. Ooh, I like your answer. Right here. And then there's another one over here, right? But why am I not looking over there? That's right, because of that, right? So I'm not allowed to look over here. But also, I don't know who said it, but you said it correctly. We have to take that angle going backwards, right? We can't come all the way around. Can't do that. You have to go backwards. So the correct answer to this would be negative pi over 3. Okay. Hang tight. I'm going to bring up your homework assignment. I'm changing your homework assignment. You're not going to do what's online. So sorry. Ebook. Where the heck's the e-contents? There we go. So you all have access to this ebook, right? When you go online? Right? Yes?
Yes.
Okay. So here's what I'd like for you to do. I'd like for you to open up, I'll tell you what page it's going to be on. Page 620, let me close this. Yeah. Is that it? That's a different page. What the heck? Yeah, that looks good. We can do this. All right, so it's page 639. All right. And I want you to look at, on that page 639, problems 9 through 69. Can y'all see what those are? Can y'all kind of see those? It's just a bunch of shit that we've been doing today. Like, y'all see it? I want you to look at those. Try to do all the odds. I know that's a lot of problems, but the first set of problems, like 9 through, let's say 19, those first set, that's basically what we started class with today, right? Where I say, oh, what's, like, look at number 9 if you can tell what that says. You know, what's cotangent inverse of root 3? Well, that really means, right, cotangent of what angle is root 3, right? But that really means what, right? And we do all that. And then for 21 through 31, you're using the calculator to get your answer. All right, so then you're going to be using your inverse functions on your calculator. 33 through 59, okay, those are all problems like we've just been doing with reference triangles, mixed in with problems where you don't need reference triangles. So like, for example, which one doesn't need a reference triangle? That doesn't need a reference triangle, because notice the inverse is on the outside and the cotangent's on the inside, so you don't need a reference. But anytime it's the other way around, you have to do the reference triangle. Work through those, and then the last ones are finding the algebraic expressions. That's a pretty big homework assignment. I'm not going to force you to do, like, you're all adults, right? You need to do as much as you need to do to be comfortable. And nothing's stopping you from doing all of them. I'm just saying the odds to me would be the minimum for you to be comfortable, all right? I usually don't assign homework out of the book like this unless I feel like it's an important assignment. I think this is an important assignment, so that's why I'm asking you to do it out of the book. I'd like for you to turn something into me next class. It doesn't have to be every single odd problem, but it needs to be a majority of problems, right? Yes? You'll turn that in next class. That'll be turned in as a quiz grade, all right? So don't do it in your spiral. Have it ready to turn in. If you write on tablets, if you do have a tablet that you write on, you want to submit it electronically, you can do that as well, but you'll just have to email it to me. All right, any questions? Okay, we still have 15 minutes. I'm going to let you go if you're happy. If not, I'll stay here and we can work through some of these together. You know, I'm not in a hurry to get out of here, so whatever you want to do. All right, that concludes 8.2. We'll start 8.3 next time. 8.3, solving trigonometric equations. Which, if you remember, I don't know if you remember, my Cal 1 students, I tell them the two things you need to know from pre-cal, the unit circle and how to solve trig equations. We are going to start solving trig equations next class. All right? You too.
So I went to the.
Hold on, let me turn this off.
Sure.
Yep.